Alright, so inverse functions. What we have here is a new idea that I guess you could say functions can be reflected along a particular axis. In this case, we'll find out what the axis is in a moment. Let's read through this. An inverse relation is obtained by exchanging the x and y values of the original relation. The graph of the function and its inverse are reflections of each other across the line y is equal to x. Only one-to-one functions have inverses. So that's an important bit because that's what we looked at in a couple of chapters ago, where sometimes there are particular graphs that aren't one-to-one, but we can make them one-to-one to find its inverse. So that's why we need to be wary of that. So addressing what I said at the start, it's a matter of, I guess you could say, flipping or I guess interchanging the x and y values. So I'll give you a quick example here, a drawing of what an inverse might look like. Okay, so if a graph, we're gonna reflect along this axis now. So this is y is equal to x. Imagine that's a mirror. If I have a function that looks like this, okay, if we flip it along, or if we reflect it along this y equals x axis, what happens is that this graph will end up being reflected like this. Okay, obviously the details of it's not that great, but that's the idea, that it's reflected along that particular line. What happens if we've got numbers though? So let's look at this example. Sketch the graph of the following, then sketch the inverse. So 3, 6 would be along here. So 1, 2, 3, 6 down here. 3, negative 6, sorry. 4, negative 4. So go across to 4. 1, 2, 3, 4. Negative 4. 4, negative 4. 5, negative 2, so 5, negative 2 would go here. And 6, 0 would go here. Okay, quite coincidentally enough, this looks like it will make a straight line if you join it up. Oh, that's off. So, at this point, we don't want to make it a straight line. Okay, we probably make that association it is a straight line, but we don't want to make that at this point because it's not the actual. You haven't been given a formula. You've been given 4 coordinates. So to find the inverse of this, what we need to do is we need to make sure we draw that y equals x line on the axis, which I'll do now. So we'll insert that line. Okay, y equals x, it passes through 5, 5, and it also has to pass through the other way as well. So let's draw a shape going down this way, and it passes through those corners as well. Okay, so that's our, I guess you could say, mirror. What we need to do now is we need to reflect it along that particular axis. So this part here will now be no longer 6, 0, it'll be 0, 6. Okay, the next one, 5, negative 2, will be now negative 2, 5. I'm anticipating something wrong with my axis here. Negative 2. The next one will be negative 4, 4. So 1, 2, 3, 4. And the last one will be negative 6, 3. So you can probably imagine, sorry guys, this one here is supposed to be around there. So this is going to be negative 6, 3. This one's negative 4, 4. This one is negative 2, 5. Okay, so if you think about it, we're literally switching these the x and y coordinates. Okay, and you've actually drawn the inverse from this particular point. Keep in mind, if I was going to ask you what the domain and range is for this graph, I know it doesn't ask us. Let's talk about the domain of f negative 1. And I want you to think about the range of f negative 1 as well. So the domain and the range of this particular inverse. Okay, so the domain of the inverse will be, let's see, the domain will be from negative 6, negative 4, negative 2, and 0. And let's think of the range of the inverse. The range of the inverse will be from 3, 4, 5, 6. Keep in mind, I'm actually identifying them as actual single numbers because it's not, we don't want to include numbers, say 3.5, because there is no number 3.5 that's actually been listed here. We're only being told the number is 3, 4, 5, 6. Now, to take it to the next step, what I want you to do is I want you to work out the following things. I want you to work out what is the range of f, and I want you to work out what is the domain of f. So this is the original red function. So this is the original red function. This is the inverse. Let's do it in red. So the range of f, going up and down, we go from negative 6, negative 4, negative 2, 0. And if you see going across the domain, that's 3, 4, 5, 6. Wait a second, there is something that's going on here. Why are these two the same? So we have come up with our next idea that the range of the inverse, so range of f is equal to the domain of its inverse. And likewise, the domain of f is equal to the range of its inverse. So these are two important formulas that we need to have a look and apply to the sequential questions. All right, so let's move on. With question B. Now, this question here does not have a particular formula for it, but we have to draw on that idea that everything is reflected along the line y is equal to x. So let's put in the y equals x. Okay, and this particular inverse would just be reflected along this line, which would show, hopefully I can do this accurately. Okay, that particular line there. And it might be a little bit long, but it's just the general shape that we're looking at, that it's reflected along y equals x. So it's important to draw that first. Now, question C, this one here is a parabola. Now, if we draw a rough sketch of a parabola, parabolas look like this. Now, here's something you have to be very careful of. Only one-to-one functions have inverses. So if you don't have a one-to-one function, if don't have one-to-one function, you need to restrict. You need to restrict. And this is what the question's asking you. It's restricting it for x is greater than 0. So this graph will appear to be in this direction. Okay, and we need to draw the inverse, which will actually be reflected along the x-axis. So I'm actually going to draw just the positive component because I want you to understand this bit. So, and let's draw the line x equals 0, actually equals y, sorry. Okay, that really shouldn't be into, the only intercept should be at 0. Okay, our inverse will look like this. Okay, so we know how to do it by sketching. The question is, what's the actual inverse? Well, if you have y is equal to x squared, to find the inverse, inverse, we have to switch the x and y values. So x and y values, you have to switch, literally switch the position of those two. So what you end up getting is x is equal to y squared, and we still want to get y by itself, so square root of x is equal to y. So I guess the important thing to note down with this is that if you ever want to find out the equation of an inverse function, switch the x and y positions and you will find this inverse equation. And it kind of makes sense in a way, because if this is what the squared looks like, this is what the square root looks like, and we have looked at that in the previous chapter, that that's what the shape generally looks like. Okay, we'll find the exact coordinates and we'll be a bit more specific later on, but for now, that's the idea of inverse functions. And let's look at the last one here. See if you can pause the video and do this one before I do. But I'm going to try this one out now. So 2x plus 5. I'm going to find the inverse. So f minus 1. I'm going to switch the x and y values together. So that becomes x is equal to 2y plus 5. X minus 5 is equal to 2y. And so y is equal to x on 2 minus 5 on 2. Okay, so this is y minus 1, or actually just to be more consistent with what we're talking about, this is going to be f minus 1x. Okay, and this is f of x. So let's put these two on a graph and let's see what they look like. So you can see with this graph here, the green line is y equals x. Okay, so that's our mirror in a way. This was our original graph here, where we have points at 0, 5. We've got points at negative 2.50 by finding the intercepts, and we've also got one at 5, 15. Okay, and this one here, the intercepts will actually be, as you can see, reversed. Okay, and we have this particular graph as our inverse for f. Okay, and so that concludes the inverse. So the key points we need to make sure that we make are inverses can only be done with one-to-one functions. Make sure you draw your mirror or your line of symmetry, which is y equals x. It's always y equals x. Another one you need to note down is the x and y coordinates switch. The range is equal to the domain of the inverse, and the domain is equal to the range of the inverse. Okay. If you're given a diagram, just draw and flip along the axis. And if you have a function that's not one-to-one, you need to restrict it. Okay, and the last one was, I guess you could say, the line. This graph is as such. Okay.